It's 3 a.m. and you get a call. You've been compromised. How? You're not sure. But you have been. Your mind is racing. What happened? And what happens next? As you work to contain the breach, you realize that the attacker had obtained domain admin privileges. Game over, right? But you start to notice something strange. The attacker isn't stealing data or causing chaos. They're actually doing things that seem helpful. They're patching systems, fixing vulnerabilities, and implementing security policies that your team had been struggling to get in place for months. Now, I think we can all agree that real attackers are not so kind, but that somewhat ridiculous example is all to illustrate a clear but key point. Admin is not the end. It's a means to an end. What matters the most is what they do with it. So I'll take a moment to plant the question in your minds. You can think about your own environments. What are you worried that they will do? And to that question, another. How would you, with all your knowledge and access, destroy your business? Hi everyone, my name is Ryan Saridar, and for the past year I've been spending much of my time focusing on those two exact questions. Today I'm going to be talking to you about building tailored security controls for the attack paths that matter most. First things first, I'd like to congratulate you all, because you're about to join me on a new venture. We're going to run a DNO together. And don't worry if you don't know what that is. It stands for Distribution Network Operator. A DNO is effectively a company that helps to manage the backbone of the UK's electrical supply. There are 14 regions that are managed by DNOs, and there are 6 DNOs that do that. Now 7, including us. Now, I know I've got you all very excited for the riches we're going to make together, but unfortunately I do have to tell you that this business is imaginary. But as this business is imaginary, we get to do something that I'm sure many business owners would love to do, and skip past all the hard work of getting it set up and head straight into the success. A minute ago, I asked a question. What can someone do to disrupt your business? Well, now we can think about the business we run together. And to answer it, we need to consider, what does our business do and how do we do it? That what question will tell you the end goal of our attack path. That's the thing you're worried the attacker might achieve. The how will tell you how they get there. Now, of course, this is a simplified model. To fully answer the risk question, we need to consider not just fulfilling our business function, but other top-level objectives that the business may have, such as legal compliance, financial growth, and one that's particularly important for our business, health and safety. But if we start exploring all of that now, we could be here a while, so I'll focus on our core business activity. So what do? Well, we distribute electricity. So at a high level, our attack path is leading to the disruption of our ability to do that. To understand in more concrete terms what that would look like, we need to ask the how. If only we hadn't skipped past building our business so we actually knew how it worked. But don't worry, I'll catch us up. To help with that, let's have an overview of how electricity supply in the UK works at the moment. Full disclaimer, I'm not an expert at this. I'll do my best to keep things accurate, but it may be imperfect. Just like yourselves, I only got into this business a couple of minutes ago. This diagram gives us a good picture of electricity supply in the UK. There are 3 main components involved in getting electricity to your home. Power generation is, I think, fairly self-explanatory. The transmission network is responsible for getting generated power to the distributors, and then each of the distributors, us, are responsible for getting that power to the end users. You will notice, though, that there's no reference of an energy supplier here. And it's important to note, just so you know where our business stands, that although we, the DNO, are distributing electricity to the customers, we are not the energy suppliers that they've signed up with. Energy suppliers are effectively resellers. They buy electricity from the power generators and pay fees to the transmission and distribution network owners to get the electricity to their customers. Some companies do wear many hats, but these roles are fundamentally different from each other. Now that we have a better understanding of the bigger picture, we can begin to see where we fit into it all. The input to our system is where we get electricity in from the transmission network. That electricity goes through a network of cable-connected substations and eventually lands on customer premises. Electricity comes in from the transmission network at a high voltage, very high voltage, somewhere in the scale of 400,000 volts. That's done because higher current leads to a greater power loss, and by raising the voltage, you can transmit the same amount of power with a lower current, thus minimizing that loss. We'll receive this electricity from the transmission network at our primary substation, which will use transformers to then step down the voltage somewhere in the scale of 100,000 volts. It'll be stepped down even more across the network by the other substations as it gets closer and closer to client residences, which are about 230 volts. These substations aren't just responsible for changing voltages though. They distribute power to different parts of the network as they have multiple distribution feeders out of the substations. They regulate voltage, keeping the supply steady. They monitor the flow of electricity in and out of the site. And they protect the network through the use of circuit breakers and switches. And managing these are RTUs and SCADA systems. Basically, the substations are a bunch of OT sites. Now, let's have a look at the software that runs it. As I mentioned, we have a SCADA system. We have an outage management system that basically helps handle the logistics side of outages, so it will help pinpoint where the outage is, and it will also help arrange the work to fix that outage. Then you have your graphical information system. It's basically a map which integrates with a bunch of data. So you can get a physical perspective on where all of your kit is, and you could potentially even integrate with data from the OT sites to see the status of different bits of kit as well. And then you have your distribution management system, which, given that we're a distribution network operator, seems to be perhaps the most important system. That's what's responsible for managing the distribution of electricity at the sites, and that's integrating with all of the kit that's there and controlling it to do so. And I'm sure the list could go on, and while I'd love to keep going, we are here looking at this to answer a question. How do we do what we do? Hopefully that's a bit clearer now, and we can begin to ask ourselves, how can we break it? And if I were to attack this, I could choose to target the kit at the sites, but clearly there are systems in place designed to handle issues with the network. So if I hit one site, it's not great, but it's probably not going to take us down. Maybe there are flaws with the resiliency that we could look to, but this isn't immediately the most attractive target. Maybe I could hit the OMS or the GIS, but these are systems that are designed to help people do their work. They're not directly responsible for the running of the network, and the network can continue without them. What is interesting to me is the DMS. Understandably so, I think. You want to hit a distribution network, you hit the systems that distribute. What's attractive about this though, rather than impacting kit directly, is that to distribute across the network, there'll need to be coordination between substations. That means there's very likely a centralized DMS system responsible for that. If I could compromise that, I may be able to mess with the whole network. So what's stopping us from doing this? How do you know someone's not tampering with your DMS equivalent right now? That brings me to the next part of my talk. We've run our DNO and gotten some perspective on what attack paths might hurt us the most. Now I'd like to talk a bit about custom security controls and how they can help provide assurance around these things, because this is where your general detection solutions fall short. That's because they're designed to fill a common security need. An EDR solution is ready to be used by any business, whether you're a DNO, a bank, a store, or something else. They're designed to fight against the things that everyone's targeted by. And they do it very well, but it's important to understand what they don't do. They don't understand your business. They don't know what the DMS is, and even if they were to put an agent on the DMS server, it wouldn't know what behavior is normal. It doesn't know who should be interacting with the system, the way they interact with it, and the way people might try and attack it. It doesn't know that if a particular config file sits on that system and is sensitive and should really never be touched, that anyone attempting to mess with that file would therefore be suspicious. So if someone were to mess with it, it wouldn't know anything's wrong. To bridge this gap, we need to implement custom detections that are based off of an informed understanding of the underlying operations. This isn't just theory though. I'm going to quickly run you through some real-world examples where we've done this. We talked about the DMS, the OMS, and the GIS, and I've now got another three-letter acronym for you, the TAS. It stands for Terminal Automation System, and don't worry, this isn't going to turn into another class. All you have to know about this is that it helps run operations at a fuel terminal. We've gone to a different industry now. We asked ourselves these questions about it. How might someone attempt to target it? And if someone had gained access, what type of behavior might we expect to see from them? So, we looked at the ins and outs of the system and built some detections around those answers. We implemented things like integrity and access monitoring of key files on the system. That means if someone attempted to modify sensitive files, we'd know. Application detections for suspicious authentication attempts. That means detecting when a host is sending numerous failed login attempts, detecting when an application has any attempted authentication bypass attempts, etc. And detecting abuse of application functionality. So of course people are going to be using these systems. It's about understanding what behavior is normal and what behavior is not. With this, it may be the case of looking at detections into someone doing certain destructive actions that might impact the system. I'd also like to run you through a second example, this time in the financial space. For those of you who are unfamiliar, Swift is basically a financial messaging system. Therefore, if you can control the messages being sent through that system, you can potentially issue fraudulent transactions. Back in 2016, exactly this happened, when the Bank of Bangladesh was breached by what's believed to be Lazarus, who are a North Korean state actor. They used a targeted phishing campaign against bank employees to gain initial access. Once they had access, they deployed Swift-specific malware. They used this to send fraudulent transfer requests totaling nearly $1 billion. Fortunately for the bank, most of those requests were blocked due to a misspelling in the payment instructions. Definitely a costly mistake for Lazarus. Despite that, about $101 million was successfully transferred, and only about $38 million of it was eventually recovered. So I think that establishes the importance for care when it comes to this environment, and although it's too late for the bank, it's not too late for others. And there are two things I want to highlight here. Firstly, I want to mention very briefly some stuff we've done in this area. In one Swift environment, we deployed process-based detections to identify any unexpected suspicious activity on the server. And we set up file access monitoring around the Swift encryption and decryption scripts. So if someone has landed on that server and is trying to track down the encryption key to manipulate some messages, they'd be caught. In an environment like that, where one would very rarely access those scripts, it's very easy to validate whether or not the access was legitimate. But more than this, I want to highlight the potential for future work. In response to the Bank of Bangladesh incident, Swift, the organization this time, established the Swift Customer Security Program, which requires annual assessments around a set of controls that they publish. But we could build tailored detections for some of these controls, thereby having not just annual assurance, but continuous assurance around them. Hopefully that gives you guys some good ideas around the type of controls that you may be able to employ. And whilst it can take some work to familiarize with these systems enough to determine valuable detections, the detections themselves are quite straightforward to implement. So next, I'd like to show you just how simple it can be to get started on this. Despite my comments earlier on what generic detections can't cover, it's very possible that the same tools that provide you generic detections may support you building tailored ones. I know this is true for Defender at the very least. But for this demo, I'm going to be using a platform called Lima Charlie. So to get started here, I'm going to start by establishing some file integrity monitoring rules. I'm going to use that for the demo. I'm setting up a file here named sensitive with a very strong control saying do not edit in the file. And now I'm going to show you what it's like to use Lima Charlie to notify us whenever that file is modified. Here you can see I'm setting up the integrity rule. And I'm just going to put in the path of the file there. And it's set with generate detections on, so it's automatically going to now be generating file integrity monitoring events whenever the file is modified, and it's automatically created a rule for us, which we can see here, that is going to take that file integrity monitoring event and trigger a detection for it. At the moment, the action is just set to report. Now, if we go into the specific host and have a look at the live feed of data, I'm going to now go back to that host and modify the file so we can see what happens here. And as you can see, there's a whole bunch of events that have popped up, including this file integrity monitoring hit. And we get a bunch of data about the system and who's caused the action and so on. Now I'm going to go and show you the different types of approaches we can take with this, because beyond simple reporting, you can also trigger automatic actions such as isolating the system, which I'm going to demonstrate. So in the case of this, it's as simple as going to the action on our detection and modifying the action to isolate network. I'm now going to go back to the system, edit the file, and show you this. To give you a bit of a visual indicator, I'm going to open up a command prompt. I'm going to just set a ping, continuous ping going. And since I've got a remote desktop connection here, as soon as the system is isolated, we're going to see the screen freeze, and so these pings will stop, which you can see now on the screen. So the RDP connection will be timed out. And going into Lima Charlie and having a look at that system, we can see that the system has been isolated. I'm just going to bring that system back up. So now if we go in our detections, we can also see the trigger that happened there. And if I go back to the system, then we're going to be able to see that the access is now restored. As you can see, some general failures up top. That's basically showing that that was the period the system was isolated in and it couldn't connect out, but now we've got our feedback. So that's it. That's how easy it is to get started with simple file integrity monitoring. You can get started very easily on customized detections using just that. And that was about 3 minutes long. So it doesn't take much time at all to get going. For the various detections that we've used, we have a webhook set up as the reporting action, which sends us notification to a chat channel whenever one of our detections fires. I want to share a funny story from last week. I was getting off a call and I hear a buzzing in my ear of 1 million chat notifications going off. You know, I had assumed that people were being particularly chatty, but as I go into the chat, I can see a bunch of these notifications that are on screen. Mimikatz behavior observed. Now that's definitely not what you want to be seeing, particularly because we were getting flooded with them continuously, each showing for a different system enrolled in Lima Charlie. So it had appeared as if an attacker was compromising the environment and was rolling out Mimikatz across the entire network. Now, thankfully, as it turned out, this was just a rule that was newly created and in the process of being calibrated live. So I got to see the 1 million notifications around that detection. But it does go to show you that these rules do sometimes need a bit of calibration and work to get set up properly. So don't say I didn't warn you if you don't calibrate your rules fully. So, to recap, we went over how it's important to understand the true end goal of your attack paths. We did a simplified exercise of going through a business and understanding how someone might attack it. We then went over the need for custom detections to protect our business. We had a look at some examples of this and saw how you can get started. Through all of this, I'd like you guys to take away the following. Admin is not the end. It's a means to an end. Always remember what you're protecting. Tailored detections can go a long way in helping with that, but they should exist alongside your generic detections. It takes work to do well, but it's easy to get started. And one more very important point. If your regions happen to suffer any electrical blackouts, I have absolutely nothing to do with it, I swear. I'm definitely not taking out the competition. Thank you guys.